graphing systems of equations in order to find the solution or the ordered pair that works in both of the equations that we are given. So the first thing that we're going to do is get our equations ready to graph. In order to graph, we need to solve them for y, or we need to get them into the y equals mx plus b order. So we're going to notice that the first one is already in that order. It's already in y equals mx plus b. So it's solved for y. We're good. Our second one is not. So what we're going to do is we're going to use the commutative property of addition, and we're going to do 3y plus 2x is equal to 5. Then we're going to zero pair out the 2x. Then we're going to do 3y is equal to negative 2x plus 5. We're going to divide by 3, divide by 3, divide by 3. Y is equal to negative 2/3 x plus 5/3. So now we have it solved for y. Both of them are solved for y, so now we're ready to graph. So before we graph, what we're going to do is we're going to take each one of the equations and label the parts that we need. So the first thing that we're going to do is look at our y-intercept. So our y-intercept is when x is 0. So our y-intercept is going to be 0, negative 5. That's also our b. We're going to look at our slope. We're going to notice that we don't have any number written in there, so we know that there is a 1 in front of the x. And of course, we need to make it a slope, so we're going to write it as a fraction. They're both positive, so we're going to be going up and to the right. On our second equation, we're going to find our starting point, or our y-intercept, our b. That's going to be 0 and 5 over 3, which is almost 2, not quite. We're going to go ahead and take out our slope and write it down here for our slope. We're going to be going down 2 to the right 3. And our starting point, of course, b is going to be 0, 5/3. So we're going to go over to our graph, and we're going to go just about 2, not quite 2. That's going to be our starting point for our second equation. And our starting point for our first equation is going to be 0, negative 5. So we're going to go ahead and start with our first equation, and our slope is up 1 to the right 1. So we're going to go up 1 to the right 1, up 1 to the right 1, go back to our starting point, down 1 to the left 1, down 1 to the left 1. So now we have our first equation graphed. Now we're going to go up to our second equation, starting at 5/3, almost 2, okay? We're going to go down 2, so that would be 1, 2, and to the right 3. 1, 2, 3. Down 2, to the right 3. And then we're going to go down 2, to the right 3. Then we're going to go back to our starting point, and we're going to go up 2 to the left 3. So up 2 to the left 3, and up 2 to the left 3. Now, you'll notice that we can see where the two lines are going to intersect. But what we're going to need to do is we're going to need to go ahead and continue our slope on this first equation until it crosses our second equation. So we're going to go up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. And you're going to clearly go at least one ordered pair past where your intersection is. So we can go ahead and sketch in our line for our first equation, and sketch in the line for our second equation. And you're seeing our solution appear. So here is our solution. Here is the ordered pair that makes both of the equations work. So this is our solution to our system. And the solution looks like it's going to be 4, negative 1. And how did we find that? Because we graphed both of the equations and looked for the intersection. All right, so now we think we know what our solution is, which is going to be 4, negative 1. So we're going to come down and we're going to check it. How do we check it? We substitute in that ordered pair into both equations. So I'm going to put the -1 in for the y, and I'm going to put the 4 in for the x, and then I'm going to PEMDAS on both sides, just like we always do when we check. So this is going to be -1 is equal to, I'm going to add a line, change the sign, or keep change. So 4 plus -5 is going to give me a -1. Both sides are equal, so we know that that solution or ordered pair works for this equation. Now I'm going to take the second equation. Again, I'm going to substitute in the 4 for the x. I'm going to put in the -1, and then I'm going to PEMDAS both sides. So I'm going to go ahead and do 8 plus -3. And then I'm going to do 8 plus -3 is 5. And of course, this side doesn't have to be simplified. So 5 equals 5 shows that I now have the solution that works for both of the equations. So now let's go to our graphing calculator and use our graphing calculator to do some checking. So we're going to go to a new doc and we're going to go to graph. And the first thing that we're going to do is we're going to put in our first equation. Now, it's going to be super helpful here to make sure that you have your equations written in slope-intercept form, because that's how you can put them into the calculator. So our first equation is going to be x, let me pull this up so you can see it. Okay, first equation is going to be x minus 5, and we're going to go ahead and graph it. If I do a Control T, I can see the ordered pairs that were graphed for me. So if I'm graphing this on graph paper and my graph doesn't look right, I can go into my graphing calculator and I can look at the actual ordered pairs that are used to create that line. If I do a Control T off, that turns my table off. Now I'm ready to graph my second equation because I'm graphing a system. So I'm going to press the Tab button. This is going to give me my second equation. I'm going to do a Control Divide because I have a fraction. And I'm going to do -2, arrow down to 3, arrow out to x. And then I'm going to do plus, Control Divide, 5, arrow down 3. And I'm going to hit Enter. Now you'll notice that I have a red line. Now when I do Control T, you'll notice that if I arrow over 1, now I have the ordered pairs that go with my second equation. My x's stay the same, and you'll notice here that I can find ordered pairs that I can graph on my piece of graph paper pretty simply because they are full integers. I don't have to worry about the fractional ones, but these ordered pairs can help me double check that I have my graph correct. I'm going to go ahead and hit my Control T to turn off my ordered pairs again. And now what I'm going to do is I'm going to see what this ordered pair is, or what is the solution to this system. So what I'm going to do is I'm going to do Menu, and I'm going to press the 6 for Analyze Graph. And on that graph, I want to look at the intersection, so I'm going to press the 4. Now this gives me a dotted line that moves. And all I'm doing is using the mouse pad with my finger, and I can move that dotted line. I want to move that dotted line as close to the intersection but to the left of the intersection as I can. And then I'm going to press on the center of the mouse pad. That's going to secure it and keep it from moving. Then I'm going to move slightly to the right until I cross over the intersection, again pressing the center of the mouse pad. And now my solution appears. And as you can tell, our solution for -1 is correct. So you can do the graph on graph paper, and then you can check it on the graphing calculator. In your Christmas packet, number 5 is a little bit tricky because of the large numbers. So I would encourage you to graph it first and then use the Control T to find the ordered pairs that you can quickly graph your 5 ordered pairs for each line and find your solution. So now you know how to graph to solve a system.